Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and finding my videos helpful. In previous video, I talked about chemical bonding and types of chemical bonding, and we discussed in detail about ionic bond. In today's video, we are going to discuss about covalent bonding. Now, what is covalent bonding? I will try to compare the points of previous video as well. I will try to compare the covalent bonding with the ionic bonding. In ionic bonding, if you can memorize, it was the bonding of ions, like in which cations and anions are combining together and they form a bond. This is called ionic bond and the compound is called ionic compound. Today we are going to discuss about covalent bonding, and covalent bonding is by sharing electrons. Ionic bonding was by complete transfer of electron and covalent bonding is by sharing of electron. Now what sharing of electron means? Sometimes some elements they do not donate or accept electrons completely because their shells are half filled, or they do not have tendency to give the electrons. Like in previous video, when I was giving you introduction about covalent bonding, I told you that carbon is the compound which has 4 electrons in outermost shell, and 4 is the half of octet rule, and half is also stable. So, not that stable, but it is somehow stable. So it just try not to disturb its outermost shell by giving or by accepting electrons. So it simply share electrons. So in sharing of electrons, what we simply observe, before understanding the sharing of electron, we must know that the compound, the element has a nucleus inside, and then it has first shell. First shell always have 2 electrons, and then second shell have 8 electrons, right? And this is the stability. This is the electronic configuration of ionic compounds. So completion of 8 electrons in outermost shell means completion of octet rule, which is electronic configuration of noble gas. So every element try to get the electronic configuration of nearest noble gas. Okay, let's have some examples in which we can observe covalent bonding. For example, we have hydrogen and we have fluorine. Previously, when we were discussing about ionic bond, I told you that ionic bond is formed between metal and non-metal. That is why group 1, 2 and 3 are metals, and group 5, 6 and 7 are non-metals. So group 1, 2 and 3 have tendency to lose electron, and groups 5, 6 and 7 have tendency to accept electrons. So they both form cations and anions and they combine. In this case, the covalent bonding is always between non-metals, right? Now, I just took an example of hydrogen and fluorine. We know that hydrogen is a gas and it is a non-metal, and fluorine is also a gas and it is a non-metal. So, hydrogen has 1 electron in outermost shell and fluorine has 1 and 2, and then 1, 2, 3, 4, 5, 6 and 7 electrons in outermost shell. Now hydrogen needs 1 electron to complete its duplet rule, and fluorine needs 1 electron to complete its octet rule. So in this way, they both will decide to share this 1 electron. So this 1 electron will be shared with fluorine and hydrogen, and here fluorine will have 8 electrons and hydrogen will have 2 electrons because fluorine is also sharing 1 electron. Hydrogen is sharing its 1 electron with fluorine and making fluorine 8, and fluorine is sharing its 1 electron with hydrogen and making it 2. So both are stable now, and the bond which is formed between hydrogen and fluorine is called covalent bond, and 1 electron is shared. That means it is a single covalent bond. Now this sharing is two-way sharing. Hydrogen is sharing its one electron with fluorine and fluorine is sharing its one electron with hydrogen. That is how they have completed their shells. So if we have any single bond, that means two electrons are shared between these two elements. I hope this point is clear to you all. For gaining stability, elements, particularly non-metals, share their outermost shell electrons and forming a bond which is called covalent bond. I gave you an example of hydrogen and fluorine. So they are sharing electron and forming one line, one bond. One bond means two electrons because sharing of electrons are always two-way, not one-way, right? So by this point must be clear to you all. Now, what is the chemistry of single covalent bond? What is double covalent bond? What is triple covalent bond? What is this structure that I drew and how to write? This is the detail that I am going to give you because this topic is very important. Usually questions come where they ask you to draw the structural formula, they ask you to draw the number of electrons in outermost shell, they ask you the ions and this kind of questions. At the end of this video, I will give you some questions regarding these topics from past papers of O levels, right? Okay, let's move to the next point. Now this dot and this cross, what is the chemistry of this dot and cross? When we discuss about covalent bonding, we talk about molecular formula, we talk about structural formula, and we talk about dot and cross formula. Now they must ask you or they must describe you in the question that they want dot and cross formula of outermost shells or they want dot and cross formula of the whole compound. Usually they ask about dot and cross formula of outermost shells. So I am giving you an example. Example is CH4, carbon and 4 hydrogens are attached with it, right? So molecular formula is CH4. Structural formula will be C is having covalent bond with hydrogens like this. And now it's time to draw the dot and cross formula. In previous class, I told you that carbon has central nucleus and the outermost shell has 1, 2, 3 and 4 electrons of itself. Now, hydrogen is sharing electron with carbon. This is one hydrogen, this is second hydrogen, this is third hydrogen and this is fourth hydrogen. Hydrogen has 1 electron in outermost shell. Every hydrogen has 1 electron in outermost shell. Now that hydrogen is giving that 1 electron to carbon and carbon will have 8 electrons now. I am drawing the electrons with green one so that it will be clear which one is shared. Hydrogen's electron will be here 1, 2, 3 and 4. Now carbon has 8 electrons in outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. Right? Hydrogen had 1 electron. So hydrogen will get 1 electron from carbon. Every hydrogen is getting 1 electron. I am showing it with black. So now hydrogen has also 2 electrons. So it is clear that hydrogen has 2 electrons now. Carbon has 8 electrons now. Both of these elements are combined together, and by combining together they are stable now by forming covalent bond. This particular line is known as bond and this is the single line, so that means it is a single covalent bond. Another very important example, this was heteroatomic example. heteroatomic. What heteroatomic is? Heteroatomic. Hetero means different. So different atoms or different elements when combined together and form a compound is known as heteroatomic compound. So we have carbon and we have hydrogen. Both of them are different. So this compound is heteroatomic. Now let's discuss about the example of homoatomic molecules. Homoatomic. Homo means same. That means elements will be same. Like molecular formula be H2, O2, Cl2, F2 and so on. The elements which are exist in the form of diatomic and they are also same elements, that is called homoatomic. Homoatomic and diatomic. We can use both of these terms for them. So hydrogen structure formula will be this. Oxygen will have double bond, chlorine will have single bond and fluorine also will have single bond. Now what is the chemistry of double bond? I just told you that when there is one bond, that means 2 electrons are shared. When double bond, that means 4 electrons are shared. And when triple bond, that means 6 electrons are shared. And triple bond is the maximum bond. Not more than 3 bonds can be formed at a time. Triple covalent bond at a time. Otherwise, we saw the example of CH4 in which there were 4 bonds, but 4 bonds with 4 different elements. With one element, there can be a triple bond is the maximum bond. That means 6 electrons will be shared and 3 bonds will be formed. Now hydrogen, this is hydrogen and it has 1 electron. This is another hydrogen and it has 1 electron. Both of these hydrogen will come together and they will share their electrons. This is the shared electron. So both of hydrogens are now stable and it form a homodiatomic molecule. Homodiatomic molecule. If you can revise the previous topics or you could see the lectures of mine. So I told you the examples or the definitions or the differences between the compound and the molecule. So compound is formed when different elements combine together. Different, like one is carbon, other is hydrogen and they are combining together. It is called compound. When same atoms, same elements are combining together, they are forming molecule. For example, all of these are molecules now, but HF will be compound. These are molecules and this will be compound. So when we are discussing or when we are studying something, try to revise the previous concepts so that they will be sure, they will be very sure in your mind and you will be clear about them. Now other example is of oxygen. Oxygen will have double bond. So let's see. Atomic number of oxygen is 8. First shell will have 2 electrons and second shell will have 1, 2, 3, 4, 5 and 6 electrons. And total are 8 number of protons and 8 number of electrons in neutral state. Then we have another oxygen nucleus, 2 electrons and then 1, 2, 3, 4, 5 and 6 electrons. Now both have 6 electrons in outermost shell. Both of the elements are deficient of 2 electrons. So they will simply share 2 electrons with each other. 2 electrons of this oxygen will be shared with this one like this. And 2 electrons of this oxygen will be shared with this one like this. Now both of the oxygens will have 8 electrons and 2 electrons are shared, 4 electrons are shared, that means 2 bonds. So we represent this is with dot and cross. The number of electrons which I drew as E, so they are represented by dot and cross. Let's describe dot and cross now. For example, this is one hydrogen and it has electron and we are representing that electron with dot. We have another hydrogen and it is represented with cross. So dot and cross means when we have two elements or when we have two or more than two elements, we will give a dot to one element and cross to another element, and then it will be easy for us to verify. Now cross will be here. That means cross is shared with this carbon. And dot will be here. Clear? Another thing, we have one hydrogen. We have another hydrogen. This is having dot, this is having cross, and they both are shared with each other. That is why this is dot and cross formula. As far as oxygen is concerned, oxygen dot dot, another oxygen cross cross. So this is dot and cross formula. I hope this is clear to all of you that what is a covalent compound, how the molecular formula is written, how to write the structure formula, what is dot and cross, how covalent bonds are formed, what is sharing, and how electrons are being shared. Next important point is types of covalent bonds. We have two types of covalent bonds. Covalent compounds, you can say. Bonding is done. If I talk about covalent bonding, so we have three types of covalent bonding. That is single covalent bond, double covalent bond, and triple covalent bond. Example will be single covalent bond is hydrogen, then we have chlorine, then we have bromine, then we have iodine, and so many other examples. Double covalent bond, we have oxygen, we have carbon dioxide, and so much more. For triple bond, we have nitrogen triple bond. So that means nitrogen has 5 electrons in outermost shell and 3 electrons will be shared with other nitrogen, and it is diatomic but triple covalent compound. After that, we have types of covalent compounds. Now this is something different. Here we had types of covalent bonds, and here we have types of covalent compounds. So we have two types of covalent compounds, simple covalent compounds and joint covalent compounds. In simple covalent compounds, we have hydrogen, we have oxygen, we have nitrogen, we have CH4, methane, we have fluorine gas, and so much more. In giant covalent compounds, we have three major examples. First one is diamond, then we have graphite, and then we have silicon oxide. These are called giant covalent compounds because the structure is so extensive and the bonds are so extensively combined together. That is why we call them giant or giant covalent compounds or complex covalent compound. Giant are also known as complex covalent compounds. So we have two types of covalent compounds: simple covalent compounds and complex covalent compounds. Okay, whenever we talk about chemistry, there are so many exceptions. One of those exceptions are the covalent compound is a conductor as well. I told you ionic compound was good conductor of heat and electricity because they had opposite charges and they allow the electricity to pass through it. Now, if I talk about the properties of covalent compounds, let's compare the properties of ionic compounds with covalent compounds. First of all, melting and boiling point. So ionic compounds had electrostatic force, that is why they had high melting and boiling point, but in this case they have rather relatively lower boiling point and melting point. Number 2, we talked about the conductance of heat and electricity, basically electricity. So ionic compounds were good conductors in aqueous and molten state but not in solid state. Covalent compounds are not conductors of electricity, but we have an exception. But because we have so many exceptions in chemistry, so here the exception is, but graphite is a very good conductor of electricity. This good that we use it in cells, we use it in batteries, we use it in different forms. So graphite is the very good conductor of electricity because the graphite has a structure in which structures have layers, and in the layers we have free electrons, and whenever we have free electrons cause passing of electricity from one point to another point. That is why graphite is a very good conductor of electricity. All covalent compounds are not conductors except graphite, and diamond is the compound which is not a conductor but it has highest melting point and boiling point. Other covalent compounds have low melting and boiling point as compared to ions, but another exception, that diamond has highest melting point and boiling point. Diamond has very high melting and boiling point because the compounds because the bonds are extensively combined together, and that is why the boiling point and melting point of the diamond is very high, and it is very dense, it is very strong. Other is conduction of electricity. Graphite is a very good conductor because it has layers of molecules, and in the layers we have free electrons, and free electrons cause conductance of electricity. Is this clear to you all? Now if I talk about chemical bonding, two topics are clear and I've taught you. First one was ionic compound. I told you the types of chemical bonding, and then ionic bonding, and then covalent bonding, and then ionic compounds and covalent compounds, simple covalent compounds, complex covalent compounds, and then their properties. So we are done with all of these things till now. Next topic will be of metallic bonding, and after that the topic will be of coordinate covalent bond, and after that there will be a lecture of revision in which I will make a table and I will give you that table in which all of the compounds will be simplified and shortlisted so that you can compare and learn all the properties of compounds clearly. I hope this video was very helpful. Now I am going to attach you some questions in next few slides. Try to solve those questions, and if there is any confusion or any difficulty in solving questions, so you can message me on Instagram and you can comment me in the video, and on Instagram I am attaching my Instagram handle as well. So see you in the next video. Take care. Allah Hafiz.